Hello everybody, this is a tutorial for my Year 12 method students. What I'm hoping to do is to run through most of the ideas in Chapter 1. We'll be starting out in this presentation with focusing on some of the parts of 1b. Now what I'd like to do in this particular presentation is to focus on the domain and range of the simple functions, things you probably should remember from Year 11, but we'll run through it anyway. So for some function f that has x values between -3 and 4, what range values can we have? Now this particular part up here is the codomain. Now the codomain, or the domain, maps onto the codomain. What that means is some x values will give us y values. Now the range says specifically what y values we should have. Now you might recognize this graph. This graph is a linear graph. Now if I just draw it a bit here, let's see, the y-intercept will be at -1, and my graph is linear, so it goes in a straight line. Now it exists between two values. It exists between -3 down here and 4 up here. Now what y values does it exist between? Alright, well let's see if we can work that out. If we put in place of x -3, that'll be 2 times -3 minus 1. Well, 2 times -3 is -6. -6 minus another one is -7. So the lowest x value I can get down there is -7. Because the x values are contained between -3 and 4, the y values have got to be contained within that. So that'll be -3, and I'll figure out the other one now. Well, what about if x is equal to 4? Well, everywhere there's an x in this expression, I'll put in a 4. So I'll go 2 times 4 minus 1. Well, 2 times 4 is 8. 8 minus 1 is 7. So my value up the top here is actually a 7. So that would mean the range is between -7 and +7. Now here's the next example, and this time I've turned from a linear graph into a parabola. Now what I need to do is to find the range for this one. Now let's think about this for a moment while I sketch it. A parabola has a turn in it somewhere, so I've got to be careful where I put the turn in. Well, let's figure out where it is. So if I were to complete the square on this, let's see, that'd be x squared minus 2x. Now at half the 2, that's -1. -1 squared is 1. So I could put in a +1 and a -1. And that would mean these three would become a perfect square. X minus 1 squared plus 2. Okay, so that means the turning point is here at 1, 2. So my graph will go down like this, turn around at the turning point and come back up. Now it'll stop here at -2 and it'll stop here at 3. So what values will the range be? Well, the lowest value will be 2. That's where the turning point is. So my range will be between 2 and something. Every point on the parabola is higher than 2. So let's check each of those. So if I say, righto, well what about if I put in -2 in place of x? Well, that'd be -2 squared minus 2 times -2 plus 3. Well, -2 squared is 4, a minus times a minus is a plus, 2 times 2 is 4, plus 3. Well, 4 plus 4 plus another 3 is 11. So that's a possible highest point, that's 11, so it'd be -2, 11. Let's put in 3 and see what happens. Well, that'd be 3 squared minus 2 times 3 plus 3. Well, that'd be 9 minus 6 plus 3. Well, 9 minus 6 is 3. 3 plus 3 is 6. So this value, and I probably haven't drawn it particularly well, 3, 6. This point is higher, so the domain will be between 2 and, the range will be between 2 and 11. Alrighty, now here we have to figure out the domain and range for this particular graph. Now this might not look like one you've seen before, but it actually is a hyperbola. Now, this fraction bar is another way of writing divide. So if I say, how many times does x plus 2 go into 2x plus 3? Well, probably 2 times. And if I divide the polynomials here, 2 times x is 2x, and 2 times 2 is 4. Now, if I take them away from one another, 2x take away 2x is 0, and 3 take away 4 is minus 1. So I could write this function f of x as 2x plus 1 over x plus 2. I can rewrite that and say, well, there was 2 times that this went into this, and there was a minus 1 remainder. Now if I write this the other way around, you'll remember that this is the form for a hyperbola. Now let's see here. The minus 2 on the bottom will shift the hyperbola 2 to the left. So there'll be an asymptote at x equals minus 2. And there'll also be a horizontal asymptote at plus 2 because the plus 2 moves everything up 2. So there'll be an asymptote there. Now normally hyperbolas would go like this and like this if they're positive. We have a negative hyperbola. Our hyperbola will go like this and like this. So what will be the domain and the range? Well, we can get any x value we like except for x equals minus 2. So I can have all real numbers except for minus 2. Now what range can I have? Well, I can have all real numbers except where there is no value for our hyperbola, and that happens when y equals 2. Alrighty, so there's our domain and range for this problem. Okay, well here's the fourth problem in our sequence of domain and range. Now, I don't know whether you remember this one. This graph is called a truncus. Alright, the minus 3 means it is moved across on our axis across to x equals 3. And the plus 2 means everything is moved up 2. Now see how there's a minus on the top line here? Usually a truncus would go like this. It wouldn't hit the asymptote between the two, and it wouldn't hit the horizontal asymptote down here at y equals 2. With the negative, that flips everything over, so it looks like this and like this. Okay, so what x values can I get and what y values can I get? Well, I can get any x value that I like except on the hyperbola. So that'll be all real numbers except for 3. Now what y values can I get? Well, let's see. Remembering that I'm down here like this and there. Well, my y values will keep going and going and going, so I could go all the way down to negative infinity. Remember, when you're doing a negative infinity or a positive infinity, round brackets. And that'll go up to 2. Will our graph ever reach 2? No, because it's a hyperbola. So we can say up to 2, but not including 2. Alright, so there's the domain and range of a truncus. Now, here's the last example in my presentation at the moment. We want to find the domain and range for this graph here. Now, if you don't remember what type of graph this is a circle. Okay, now the circle will have a center at center. It'll be the opposite of minus 1, so plus 1, and the opposite of plus 2, minus 2. So the center is at 1, minus 2. And the radius of our circle will be the square root of this number there, which means that the radius is 3. So if we were to sketch our graph, here's what it would look like. The center would be at 1 across, minus 2 down. Now, because the radius is stretching 3 in all directions, I could go straight across here, and from 1, 3 across, that would take me to 4 minus 2. And from 1, 3 back, that would take me to minus 2 minus 2. From this point, from the center up 3, that would take me to 1, 1. And from 1 minus 2, 3 down, would take me to 1 minus 5. So I'll go around and my graph would touch each of these points. Now, that helps me figure out what my domain and range will be. Now, let's see, what's the lowest x value I can have? -2, and the highest x value I can have is 4. Now, what y values can I have? What's the lowest x value that I can have? -5, up to the highest y value that I can have? 1. So there's the domain and range for this circle here. Alrighty, well I hope that helps with some of the things you're studying in 1B. I'll see you in class and hopefully I can help you out with anything you don't understand then. Alright, bye bye.